Welcome back, Leo Lions. This is Mrs. Morgan with today's lesson over volume with cones and pyramids, but we're doing it a little different. We're going to get some practice where the volume is given and then we are solving for something else, whether we're solving for the radius or the height, or maybe the base shape has a missing side length. So we're going to be working with the volume formula, but remember we're going to replace this time the variable, that capital V for volume, and then we're going to have either the R or the H, and one of those is going to be missing. So volume of a cone, I have our formula there. Remember, volume, cones, and pyramids have the same formula, but this capital B gets replaced with the area of the base. So I realize there is not a lot of room to show work on this worksheet in Shobi. I am going to zoom far in and write so that everything is small. If it is beneficial to you to use a piece of paper, I would do that if you prefer. So here is what we are going to start with. Every time I would write out what is your formula. Volume for a cone, 1/3 times pi r squared times the height. So I am going to replace what I know. I am given the volume, so the capital V gets replaced with 147, and it's given to us in terms of pi. The 1/3 is in the equation, times pi. We know that's 3.14. And so on. It's an infinite number. Here in our cone, we have a radius. It is from the center to the outside, so I'm going to replace the R with 7 squared. And then the height is what we don't know. That is what we are looking for down here. That's what we're missing. So I'm going to leave the variable H in our formula. And notice I put it in a different color so I remind myself that is what I am solving for. So once we replace what we know and leave what we don't know, it is basically just like solving an equation. And we want to get that variable H. It's on the right side of the equal sign, and we want it to be left all by itself. So there are tons of different routes that we can go from here. I'm going to show you multiple ways, but our goal in the end is to get rid of 1/3, the pi, and the 7 squared from the right side. In this case, I'm going to get rid of the 1/3 first. And show you how to deal with that fraction. So remember, everything's multiplied on the right side. So to undo it, we want to divide. Well, if we divide by 1/3, what we're actually doing is same change flip. We are actually multiplying by the reciprocal, 3/1. And that's how we would get those diagonals to cancel out, and that's how we get them to eliminate on the right side. So next step, we are also going to multiply the right or the left side, so that we're doing the same thing. We're keeping our equation consistent. So on the right side, we have pi 7 squared, and actually, let's simplify. 7 squared is 7 times 7. We can simplify that to 49. And then times our H. Then the left side, we just have to do 147 times 3, which I don't know off the top of my head, 441. And we still haven't done anything with that pi yet. And if you wanted to, you could have gotten rid of the pi first. It really doesn't matter. All right, next step. Again, everything on the right side is being multiplied. So to undo it, we're going to divide. I'm actually going to divide. You can divide by pi and 49 at the same time. That way we get rid of the pi divided by pi, 49 divided by 49, they all go away. So we got to our goal, and actually I'm going to scoot it up a little bit. We got to our goal of H all by itself. Now, whatever we do to one side, we have to do to the other. So we also have to divide this 441, divide by pi. I'm going to put pi right underneath it. And we also have to divide by 49, since that's what we did. So pi divided by pi, those cancel out. And all we have to do then is 441 divided by 49. And there we go. We have a whole number 9. So the height of this cone is 9. And then our radius was labeled in feet. So the height is 9 feet. And there we go. All right, I'm going to do several examples with you. Notice when I zoomed in and then I zoomed out, there was plenty of room to show work. I actually had extra room. So next one, I'm going to go straight below to this one where we're missing the radius. And I'm going to do the exact same steps. Start out with what is my formula I'm using. Volume is 1/3 times pi times r squared times height. Replace what we know, so the v is going to be replaced with 500 pi equals 1/3 times pi times, now this one, we don't know the radius. That's what we're looking for. So we're going to leave the r squared in the formula, and then the height we know is 15. So I still have to put my times 15. Okay, we got everything replaced, so now it is just solving an equation. We want to get r by itself, so we want r on the right side of that equal sign all by itself. Now, personally, here's an example where I automatically see 1/3 times 15. I know 1/3 will perfectly multiply to 15 to a whole number. If we multiply the 1 and the 15, we'd get 15 over 3. So those multiplied are 5. And if you didn't know that, you could plug it into your calculator and you would see that it is 5. And actually, I'm going to leave the r squared to remind myself. That's what I'm trying to get by myself. So all I did was multiply the 1/3 and the 15 and combine those to 5. And everything else then stays the same. Now, again from here, I'm going to do 2 steps in one because I want to get rid of the 5 and the pi. And we can divide by both of those at the same time. So 5 divided by 5 is 1, pi divided by pi is 1, and now we have r squared on the right side by itself. So we're close to our goal. Now the left side, pi divided by pi, again, those are 1 as well. 500 divided by 5, and we get 100. Last step, so remember that if we are looking for that r squared, how to get down to just r, we take the square root of both sides, and that's how r times r, that's how we get r by itself. And then what times itself gives us 10? Well, that would be 10. So 10 times 10. And our radius then would be 10 feet. And what you could do in these examples is when you're done, you could take that 10 and plug it back into the formula and do 1/3 times pi times 5 squared times h, or times 15 for our height, and see if you get 500 pi for the volume in the end, so you know if your answer is right or wrong. Okay, so there's how we find radius. Now, if we were in a question like number 2, where it's asking for the diameter, well, we could take that radius and then double it, so we know the diameter is 20 feet. So those examples that are asking for the diameter, we just find the radius and double it at the very end for the diameter. Okay, so I've given you a couple examples on this front side. This number 6, there's a couple steps involved because this one you're looking for the slant height. So if you think of a cone, and I always tell you guys, I'm no artist here. So here's my cone. We know the volume. We know the radius is 21, but we don't know the height. Remember that the height is inside the cone that comes down and forms a 90-degree angle. So that's what we're missing. We know that the radius was 21. Now, this question, like I said in the beginning here, it's looking for the slant height. So it's actually looking for the outside measurement of that cone. So in this example, we actually have to do a couple steps because we don't know the height inside. Once we find the height, notice, and I'm going to do it in a totally different color here, we'd have a right triangle. And we could use the Pythagorean theorem to find x, but we first have to find h. So for this example, we would want to follow the same method in our other examples we were doing. Start out with the formula, replace what we know. We know the volume is 4,116 pi, and then equals 1/3 times pi. We know, remember, the radius was 21, so times 21 squared. And then times h because we don't know the height. And we could solve then this equation to find the height of the cone. So again, a couple steps we could do here. I'm going to double check. I'm going to see if we can do this all at once and do my 1/3 times 21 squared. I'm just looking at the numbers in that problem. So 1/3 times 21 squared. Perfect. It comes out to a whole number. Now, if it didn't come out to a whole number, I would probably just get rid of that 1/3 and multiply both sides by 3. But conveniently, those two multiply to 147 times pi, and then we still have that times h there. And everything else on the left side we've done nothing with because we're only looking at things that are on the same side. Now I'm going to get rid of the 147 and the pi at the same time. Divide the other side. And that's how pi divided by pi, 147 divided by 147. So now we are at our goal of h. Pi divided by pi, and all we'd have to do is 4,116 divided by 147. So we get the height of this cone is 28. And some people may stop there and think that's what we were looking for, but that is, remember, inside the cone here. So we still need the variable, and actually I'm going to do it in a totally different color. This orange x is actually what we're looking for, the slant height. Okay, so the second part to this then, to find the slant height, remember we talked about that pink right rectangular angle or triangle in there. So we have the two that form the 90-degree angles. Those are called the legs, the 28 and the 21. So remember, the a squared plus b squared equals c squared, Pythagorean theorem. And we know the legs, one of them are 21, the other one's 28. And then I could do all of that at once in my calculator and do 21 squared plus 28 squared. We get 1,225. And then remember, last step, kind of like when we had the radius squared in the end, our goal is to find the value of c, not c squared. So we take the square root of both sides. And we get 35. Came out to a whole number. So the slant height is actually 35, not 28. The 28 was the height. So slant height is 35, and this was measured in yards. So there we go. I've done several examples with you on the front side. Let's head to the back side where we have some pyramids. Very similar process, except for with pyramids, we're going to consistently stick with this 1/3 capital B times height. And the capital B, it changes based on the base shape. So depending on this shape. So this is a rectangle, so that capital B would get replaced with length times width. The next one, this base of the pyramid, is a triangle. So the capital B would get replaced with 1/2 times base times height. Here we have a square, 13 by 13. So the capital B would be replaced with side times side. So the formula stays the same, but the capital B in the formula is what consistently changes. So let's start off again with our volume formula. Let's figure out the shape, what we need to change that capital B to, and then plug in what we know, leave what we don't know. So we know that that base is a rectangle. So the formula would be 1/3 times length times width for the rectangle times the height. So this example, again, remember, we're going to know the volume. So we know it is 896. The 1/3 stays. Now the length and width, we know one of them, but we don't know the other one. So it's 7 times x. And I'm going to use that variable x since that's what we're solving for. And then the height of this pyramid is 24. And actually I'm going to change that x to a red like my last examples. And then times 24. And again, my variable is on the right side, so my goal is to get that all by itself. We've got to get rid of 1/3, 7, and 24. So personally, what I would do here is all of the numbers and forget about the variable x. So on the right side, we have 1/3, we have a 7, and we have a 24. Multiply all of them together, and we can simplify this 1/3 times 7 times 24, all of those three, we can simplify to 56. And then we still have x over there. And we have done nothing with the left side. I was just simplifying all of those numbers together. So then next step to get x by itself, well, we would just divide by 56. So 896 divided by 56, we get 16. So that missing variable is 16 inches. Okay, so very similar process. I do want to show you this next one with a triangle base because we got to be careful with that capital B and replacing it. So our volume formula, 1/3. In this case, that capital B is 1/2 times the base times the height, or base times height divided by 2. And then we need the height of the entire pyramid. So let's replace what we know. The capital V is 204 times or equals 1/3. Now, this base triangle, we have 8 as the base. We don't know the height. That is our x. So when we plug this in, it's going to be 1/2 times 8 times x, because we don't know what the height of the triangle is. And then last thing, our h, we do know is 17, the height of the actual pyramid. So again, and I'm going to change that to my red X. Now, again, same process, but I'm pretty sure if we try to do everything on the right side, they do not come out to a perfect whole number. And I'm not a huge fan. 1 divided by 3, and then we did times 1/2. This is the triangle formula, times 8 times 17, and yes, it comes out. You could use the fraction if you wanted to, but I'm not a huge fan of that. So I'm going to get rid of the 1/3 because I think, yes, 1/2 of 8 is 4, and then 4 times 17, that gives us a whole number. So I'm going to do a step before that. I'm going to get rid of this 1/3, and I showed you guys how to do that on the other side. So 1/3, remember, everything on the right is being multiplied, so the opposite, we would divide by 1/3. Well, that same change flip, we're going to multiply by 3 to both sides. So to get rid of that 1/3 in either the cone or the pyramid formula, just multiply by 3. So 204 times 3, I think, is 612. Everything on the right side then, I'm going to multiply, remember that 1/2 times 8 times 17, those multiplied all together to 68. And then I still have that variable x. Now everything on the right side is consolidated to one term, so all we have to do is divide by 68, divide by 68, and that is how we're going to get x by itself. So I need to put in my calculator 612 divided by 68, and we get 9. So the height of that triangle is 9 feet. And there we go. All right, so again, very similar process for all of these. We just have to remember to change that capital B. And sometimes like this one, it's kind of like our r squared. We're going to have x squared because that base is an x, or is a square, and they're x times x. So that's similar to when we found like radius squared. So all of the other examples are very similar. I want you to get some practice with these and complete these examples on your own.